in the continuation of NR method, we are solving some question based on the transcendental equation. Okay, okay, students.
Yes, ma'am.
Yes. So we are just solving question based on the transcendental equation. So what is transcendental equation and what is algebraic equation? If any equation is in the form of polynomial, then we say it is a simple equation or this is the algebraic equation. Okay. But if there is also some special function like trigonometric function, exponent, inverse trigonometric function, or anything else, if are also included in the term, then they are called as a transcendental equation. So what we are doing, we are just finding the solution of these type of the transcendental equation, right? So suppose I am writing question x square equals to minus 4 sin x. So this is equation is transcendental equation. Why? Because in the second term you are just adding here trigonometric function sin x. So this equation I can write here x square plus 4 sin x equals to 0. Or this we can write f of x equals to x square plus 4 sin x equals to 0. So you can say this particular function or equation is a transcendental equation. So we want to find the solution because it is not easy to find the solution of such type of equation. So for this we have to use numerical computational technique. So what is that? That is Newton-Raphson method which we are using here. Okay. So your function is now f of x equals to x square plus 4 sin x. So what we do in the NR method, first of all, we have to find the root line. So for that, you just put f of 0 here because in the number line you can just consider 0 is the origin and then you can just substitute 1, then 2, then 3 and so on the left hand side. You can substitute minus 1, minus 2, minus 3, whatever you want, you can just substitute. So I am starting with the initial number f of 0. F of 0. So if you are writing this is 0 square 4 sine 0, so you will get this equals to 0. Now, to find 0 is, we cannot say if there is any sign on 0. So this we can discard. Now to find f of 1, we'll write 1 plus 4 sine 1. So if you are solving with the calculator, and what is the important thing here in this question, the important thing is if you are calculating this value from the calculator 1 plus 4 sine 1. So first of all convert your uh, calculator mode into radian. If you are converting your calculator mode into radian, then only you will get this correct answer, which is something coming, which is positive value. So this is signless, and you are getting here positive sign. So continue. Just I will put f of minus 1. So for the f of minus 1, you will get 1 plus 4 sine of minus 1. So you will get 1 plus 4 minus 0.8414. That is, you will get negative value. Okay. So negative value means your root is lying between 1 and minus 1. Okay, because here you are getting positive value and here you are getting negative value. But in the question what they have given, in the question they have given, the root should be just nearest to minus 2. So what you will do in this case, you have to substitute the value of f of minus 2 also, because they are saying that the root should be nearer to minus 2. So just put f of minus 2 also here. So if you are putting minus 2, so this will be 2 to the 4. This is 2 into 2 minus, this is minus 4. And you will get here 2 to the 4, that is positive value, plus 4 sine of minus 2. So you will get f of minus 2 is a positive value. So f of minus 1 is giving negative value, while f of minus 2 is giving positive value. So you can say definitely root is lying in between minus 1 and minus 2, because you can also say f of minus 1 is the negative value and f of minus 2 is the positive value, and the product of this is less than 0. So you can say yes, surely the root is lying between 1 and minus 2. Okay, the root which I can just supposing here as a c, the root is lying between 1 minus 1 and minus 2, right? Now, but in the uh, this nr method you have to select the initial approximation. Initial approximation means the important thing for this method is you have to select x0 first. X0, to choose the x0, either you can do one thing, you can bisect these this value, means you can find out minus 1 plus of minus 2 divided by 2. So in this way you will get minus 1.5. So you can start with the minus 1.5, or you can do one thing, just see कि which is the nearer root. So if you are just seeing here which is the nearer root to the 0, so f of minus 2 absolutely, what is the value of f of minus 2? This is 0.3628 absolutely, while f of minus 1 absolutely is 2.366. So this is the least value f of minus 2. So you can say just root is lying nearer to minus 2. So you can just start your iteration with x0 equals to minus 2, right? And they are also saying in the question, we find the root nearer to minus 2. If they are not giving this sentence, even though you have to just write here x0 equals to minus 2, because this is the root only for which you are getting the nearer value. Okay. Now we will start the iteration. So to start the iteration, just put the formula of the NR method. So this is the formula of the NR method. What is the formula? We just write xn plus 1 equals to xn minus f of xn upon f dash xn. And the use of this formula we did in the last class. In the last notes, we discussed about this, how to get this formula and how to use this formula in the algebraic equation. Now, just putting the function's value. So what is function given? The actual function which is given is x square plus 4 sine x. But you are writing f of xn. So what you will do? You will just substitute xn square plus 4 sine xn. And the differentiation of this is 2x. I'm writing 2x plus 4 cos x. So at xn, the value will be 2xn plus 4 cos x. So in this way, this is your main formula. From this formula, you can just start to find the iteration, because from the iteration only you will get the root, you will get the convergent solution. What is the meaning of the convergent solution? The meaning is in two iteration you will get approximately same answer. If you are getting into any two iteration, two approximate answer, you can say yes, this is the root. And you have to decide up to what places you want your result. In the question, if it is written up to 4 decimal places, so you have to obtain your result up to 4 decimal places. And if they are not giving, by default also you can take up to 4 decimal places, because your accuracy of the answer will be good up to the 4 decimal places. So try to take your answer up to 4 decimal places. Now, start first iteration. For the first iteration, what we will do in the formula, let's see now. In the formula, we will substitute here n equals to 0, because you are going to find first iterative value. So n equals to 0 if I am putting, so we'll get x1 here, and this is becoming x0. And for this, we'll write x0 square 4 sine x0 upon 2x0 plus 4 cos x0. So what is the value of x0 is minus 2. So putting this value, this is 4, this is sine of minus 2, this is 2 of minus 2, 4 cos minus 2. Now calculate by changing your mode of the calculator into radian and finding this calculation and getting this result. So in this way, what is x1? X1 is minus 1.9359. This is the initial approximation was minus 2. It means the value is reducing. So the answer should be nearer to minus 2. Now, just continue the iteration for n equals to 1. If you're putting in the previous formula n equals to 1, in the NR formula n equals to 1, obviously you will get x2 in terms of x1. So you'll write x2 equals to x1 minus x1 square plus 4 sine x1 upon 2x1 plus 4 cos x1. Substitute this value which you have obtained in the first iteration here. So just get the result. Again, the same thing you have to follow your calculation by changing your mode of the calculator. Okay, you have to change the mode of the calculator so that you will get your answer in the radian. So this is your x2, but these value are not matching up to 4 decimal places. So continue the iteration. Continue the iteration means if you are continuing the iteration for n equals to 2 and finding x3, so I have written here the calculation directly. You will get minus 1.9338. It means your value x2 and x3 both are matching up to 4 decimal places. So you can stop here and writing the answer. The root of the question of the transcendental equation is x equals to minus 1.9338. So in this way you can complete the question, but there is a problem if you are getting answer up to the 6 decimal places. So you have to follow more iteration, and you have to write in each step up to 6 or 7 digits. You have to write at least in each iteration from x1 x2 x, so that you can match your answer up to 6 decimal places if they are giving in the question. So this was the question number 1. Now this is very important question for the NR method. And this is also like a application ki you can find any order root, like you can find third cube root, you can find fourth root, you can find 10th root, you can find 11th root, any root you can find by the NR method. This is the beauty of this method. You can use this method as an application. So suppose here in the question we want to find the root of 12. Root of 12, any question may be here: root of 12, root of 5, root of 23, or you can also obtain 12 to the power 1 by 3. It is the third root. Or you can find 1 to the power 1 by 5. This is the fifth root of 5. Or you can find 100, this 1/10 root of 100. So you can solve any for the any root by this method, in our method. So this is the beauty of this method. You can obtain root, any root of any number by using NR method. So how we just follow this method? Let's see one example. So what is example here? The question is, this is question: find the root 12. Root 12 means you have to obtain here 12 to the power half. Find the root 12 to 4 decimal places. They have, yeah, mentioned here कि up to 4 decimal places we have to obtain the root of 12 by an R method. So what we'll do, your root is, you just want to find the value of root 12. So just assume let x equals to root 12, because you want to find the value of this x equals to 12, giving x square equals to 12, so that the function will be x square minus 12 equals to 0. And you can find f dash x also here. The f dash x will be 2x. Now first step is to find the initial root or root lying in between. So I'm finding the root lying in between, then I will just find out the initial approximation value. So first just go for the roots in which root your actual answer, actual root or actual value is lying. So if you're putting x equals to 3, because you know the value of 12. Suppose I'm asking you ki what is the root of 16, so you will say 14, 4. The 4 will be the root of 16. If I am saying the root of 9, we will say 3. So it means that and 12 is coming between 3 and 4, 9 and 16. It means the root will be in between these two. So what I am doing, I am just substituting f of 3 first in this equation. You are getting negative 3, and f of 4 you are getting positive 4. So it means that now you can check which is the less value, absolutely less value. So f of 3 is absolutely, if you're finding, so this is 3 absolutely, this is 4 absolutely, so 3 is less than 4. So it means the root should be nearer to 3. So just start with the x0 equals to, this is the best method by which you can find the solution very easily. So try this method only in the examination, this will be best. And if you are taking the midpoint, so maybe you have to follow more iteration. So just use this method so that you can find quickly your root from the NR method. Now use the formula xn plus 1 equals to xn minus f of xn, f dash xn. Now make the formula first, master formula. Xn is xn. What is f of xn? The function was x square minus 12. So you will write xn square minus 12. And the differentiation of this was 2x. So you will write 2xn. So this is now the equation number A. I'm supposing this is your master formula. Now you have to just follow the iteration and using the same formula again and again. So what I'm doing, I'm just using n equals to 0 here with the starting value x0 equals to 3, which we have decided here. So n equals to 0 and 0 equals to 3. Now finding x1 by putting n equals to 0, so you will get x1, 0 plus 1 means x1 equals to x0 minus x0 the square minus 12 upon 2x0. Putting these value here, whatever you have just put, this is a 9, this is 3 minus 12, 2 into 2 is 6. Just calculate, you'll get 3.5, means it is sure that your root is in between 3 and 4. Now go for the second iteration. For the second iteration you have to use this previous value as a x1. Now iteration is for n equals to 1, so you will get x2. Now the formula will be x1 minus x1 the square minus 12 upon 2 x1. Putting these value, getting 3.46 something 4643. This value you have 3.4643. Now for the third iteration, just again using this formula, putting n equals to 2, we will get x3 in terms of x2. X2 already you have, just putting this value and getting this. And now first check, before starting the next iteration, first check whether second and third iterations are matching. The second iteration was this and the third iteration was this. It means it is not matching up to 4 decimal places, because in the question they have clearly mentioned that you have to find your solution up to 4 decimal places. So it means you can just watch here कि yes, in the fourth iteration surely we will get the answer. You will remove the error so that your answer will be up to 4 decimal places. The answer difference in the answer is due to the error. Okay, in each step you are getting the error in the answer. And how we can remove, if you are increasing the iteration, you can remove this error. So what is the fourth iteration? In the fourth iteration, putting n equals to 3 now here. X is the previous value which you have. Just using the formula again of the NR method which we made here. The same formula which we made for this particular equation. X3 square minus 12 upon 2x3. Just solve it. So we are seeing up to 4 decimal places. Now our answer is matching. So it means our convergent result, we have the root of 12, which is 3.461, correct to 4 decimal places. So in this way, we can find any root by using NR method. This is very important for the examination, and we can add one more thing here. This is for the practice. If I am writing one question, to find the formula of the root of n and hence evaluate root of 23. So what you will do in this case, first of all, you will write x equals to under root n, because this is your question. So what is the function? Function will be x square minus n equals to 0. This is your function. Now with this function, just find out the differentiation and just make the formula of the NR method and continue with this process of NR method to find the root of 23. So these type of questions are very important for the examination. It is not necessary that the root of n to the power half is possible. We can also give the question like n to the power 1 by 10. Find the general formula of the n to the power 1 by 10. So for this case, what we'll do, we'll write n to the power 1 by 10 and taking at x to the power 10 here, so that you will get here n, and just write x to the power 10 minus n equals to 0, and just continue to make the formula and just start the iteration. Also, we can do one thing. We can use the table method which I have cleared in the last class, in the last module, not last module. We have just cleared this in the last class about how to use tabular method in the NR formula. The value, suppose you are putting in the first iteration 0, then 1, then 2, then 3. So you can just write this iteration 1, this is 2, this is 3, this is 4. Why we are stopping at 3, 4? Because right now we know In the question you are getting the answer at the third and fourth iteration. So that's why we have mentioned here. But in the examination, if you are directly using the table method, so you will just continue until you will get to same answer. Now in the table, only finding the value by using your calculator. No need to write in the copy. You can find out x1, then calculate f of x1. Just put the value for the x2. These are required. F dash x1 also required to substitute this value and getting x2, and same find of x2, finding f dash x2 also, putting this in the x3 formula, getting x3 and x4 and so on. But since x3 and x4 are matching, you will stop here and write the answer of this problem by tabular method of NR. So there are many questions we can practice, like this is also a transcendental equation. So this is transcendental equation, and just we are making the formula for that and then solving the answer. So there are many questions. I am again showing the answer of it. We can see the answer of this problem. This is e to the power x equals to 4x. The function will be e to the power x minus 4x, and the differentiation you can write. After writing this, just select the point in which at what point the root is lying. 2 and 3, because at 2 you are getting negative, at 3 you are getting positive. But what is close? 2 is close. Why? Because absolutely this value is less as compared to this value. So you can start with x0 equals to 2. Now continue with the formula. Make the formula first for the function. So this is your master formula for the function. So mark it and use it again in each iteration. The step number one, equation number one, you can use in each iteration so that you will get the root in each step to get the convergent solution. Convergent solution means if you are getting two same value, approximately same value, so you say yes, this is answer of the problem. So this is the solution. You can just see, and this is also stopping at x3. At x3 you are getting 2.1533, and at x2 also 2.1533. So in the third iteration only we are getting solution. So if your choice of the initial point is very good, then only you can get your solution very fast. If you are choosing right selection, so your convergent will fast, you will get convergent solution very quickly. So this was the NR method for transcendental equation, and this is the tabular method. You can also use this tabular method instead of the previous method. In the examination also you can just use, but you have to do every calculation on your calculator. Okay, but first of all check what mode is set in your calculator, then only you just start to solve the problem. Okay, because if once you have changed the radian and you're solving other problem, to again change the mode in the degree, otherwise your answer may be wrong. So please practice on your calculator so that you will get the right calculation in the examination. Now see, this is also a transcendental equation, cos x minus x e to the power x, and written here work is written to solve this particular equation with the table only. For the table also you have to obtain the master formula, means xn plus 1th term. So how you find? This is the formula of the NR method. What is function? The function is cos x minus x e to the power x. And what is f dash x? F dash x is x cos x plus sin x. So write all these things in nth term in the formula of the NR method, getting the general term. This is your general formula. Now start iteration in getting the result x1. This was x1, then x2, and now check at what iteration you are getting two approximate value same. So that will be your complete answer. So in this way, you can solve the problem of the transcendental equation by using NR method. The same question here I have written, evaluate under root 12 to 4 decimal places by NR method. Already we discussed this right now. Now, the second question, compute real root of x log to the base 10x. So please take care of this base. The base 10 is given, so while using the calculator, please taking the care of it. Okay, how we can just find out the value x log 10x when you will calculate your calculation. This you have to find up to correct three decimal places. Similarly, in the question number 3, find the root of cos x equals to x e to the power x by an r method by taking. In this question they have given the initial point, so no need to write, no need to select the root lying in between. You can just start the iteration by taking x0 equals to 0.5 directly in this particular question. So there are many type of problems given in the examination, and many types are cases we can provide in the examination, like either we can just give you point, or we will not provide you point. You have to search the point, the method which we discuss in the class, है ना? By the method which we discussed here. Okay, so in this way we can just see this method. So I think this is clear to everyone.